In this video, you will store logs with Loki, collect metrics using Prometheus, and combine everything together in a Grafana dashboard. This unified approach allows you to quickly identify issues using metrics and then quickly diagnose them using the corresponding logs. We're going to do all of this inside of a Docker environment, and as always in these videos, I will provide you with all of the project files you need to get set up and follow along. But before we dive right in, let's just look at the big picture. Why are we doing all this? I want to start off by making a very bold claim. People are starting to abandon Elasticsearch for the more scalable and efficient Loki. Why? Well, Loki, from the trends that I'm seeing, is becoming the industry standard for storing logs. Because say you have the following log, right? This is an example log entry. What Loki is going to do is only index the metadata while compressing the actual log content. Unlike Elasticsearch, which pretty much indexes everything and as a result consumes a lot more resources, an enormous amount of resources, especially as these enterprises store millions and millions of logs. You want a solution like Loki that is more efficient and scalable. Tracking logs is really important because it allows you to pinpoint when certain events happened, but sometimes you want to be able to capture trends and patterns over time, and that's where Prometheus comes in. Prometheus is the industry standard for storing metrics, which in turn capture trends and patterns in your system's performance over time. In our Grafana dashboard, we're going to combine both to solve a very common problem. Metrics, they show you when something is wrong, like a spike in error rates or unusual patterns. Once you identify this unusual pattern, you can quickly diagnose the problem by looking at the corresponding logs, because logs, they reveal specific events that happened at that moment in time. So this spike in error rate in this case can be explained by the fact that at 1542, there was a database connection timeout. There you go. So this powerful combination means that you can identify anomalies using metric trends and then immediately diagnose them by examining the individual log events, all without switching between different tools. Everything is happening in one unified dashboard. If you ask me, this is pretty amazing, and I don't know why most enterprises haven't already defaulted to this solution, combining Prometheus metrics, Loki logs inside of a unified Grafana dashboard. If there's one tutorial that you should not miss out on, it's this one. Let's dive right in. All right, we interrupt this broadcast with a very important message. If you haven't subscribed already, come on, hit that subscribe button. You'd be doing me a favor. All right, see you in the lesson. Cool, so inside of your video description, I left you a link to this GitHub repository that contains all of the project files you need to follow along with this YouTube tutorial, or if you're the type of person who, after watching a video, wants to read a summary of it, I left you an article that summarizes basically everything we're going to talk about in this video, but definitely recommend watching the video first because it goes into a lot more detail and walks you through the whole process, right? So let's go ahead. So make sure you go to this repo and then clone it in a directory of your choice. I'm going to clone it inside of a directory I called YouTube tutorial. Okay. I've got the folder right here. So I'm just going to go ahead and drag this to a new instance of VS Code. Let me just open this one up. Ignore what I have here currently. All right. I'm using a 4K monitor, so this whole zooming in and out thing is kind of annoying, but whatever. Adjustments need to be made. So this Docker compose.yaml is a treasure because it already configures the entire monitoring and logging stack for you. You can easily adapt this to your own environment if you understand what's going on here. All right, I'm going to briefly go over the structure of this Docker Compose environment. First, I want to point you to the log generator container, which simply generates fake logs. That's it. And here we have a metrics exporter, which generates fake metrics based on these logs. the metrics that are being exported by this container will ultimately be saved into Prometheus. The logs being generated by this log generator are going to be collected by PromQL, which is a log collector, and PromQL is going to forward them to Loki. All right? And this aligns with the main purpose of this video, because Grafana is going to then be used to query the logs in Loki, query the logs in Prometheus, and allow us to construct a unified dashboard where we can analyze the metrics in Prometheus, look out for patterns and trends, and if we detect anything unusual, we can then defer to the logs in Loki and try to pinpoint specific events that happened at moments in time and be able to troubleshoot what's going on. So that's the gist of it. I'm not going to go over the nitty-gritty of how everything is configured inside of this Docker Compose environment, because honestly, most of it is derived from the official Loki GitHub repository. The only thing that I added, which I felt was missing, was fake metrics. So this environment already had fake logs being generated, but no metrics. So I created a sample application that actually processes all of these logs and generates fake metrics based on them, just so that we're able to go through this tutorial. So just goes to show the effort that I try to put into these videos for you guys. Anyways, no effort from your part. You just got to run Docker Compose up and the whole thing is going to get set up for you. I just got to make sure to actually run Docker first and foremost. And actually, before I do anything, what I want to do is delete all the images I have so far, because if you run this a second time around and the previous configuration isn't consistent, you're going to get a lot of errors. So I deleted all my images, containers, everything is done. Just to be on the safe side, I'm going to run docker system prune -a. I just want to start off fresh. All right, now I'm going to run docker compose up. All right. Weird, I don't know why that happened. Okay, anyway, the result of this is Prometheus is going to have a bunch of fake metrics, Loki is going to have a bunch of fake logs, and we can query all of them from Grafana. So now we can go ahead and access Grafana on localhost 3000. Sorry to interrupt, but have you ever struggled to talk to certain people at work and just needed an icebreaker of some sort? Well, allow this new Podfather shirt to assist you. This shirt will cement you as a master orchestrator of pods. It obviously plays on the word Godfather, and it's purely satire. It will make your coworkers laugh. You've got Docker in there, you've got Grafana, Elasticsearch, which I recently removed in favor of Loki. And I ended up putting the Kubernetes logo in the middle. So what you will see in the store is actually the final draft. I actually ordered a few for myself. So feel free to check out the store if you want to get in on the action. We've got t-shirts, crew necks, long sleeves, mugs, whatever. And I also set up a Discord server for this channel where honestly we can all come chill, hang out, connect, talk work, give workplace stories, whatever. And whoever submits photos of themselves wearing the merch, what I'm going to do is actually select the ones that I think are funny, creative, or come with a great workplace story, and I will feature them in a YouTube video. So feel free to get in on the action. Check out the merch, join the Discord, let's hang out. Anyways, back to the video. Now, if in the future I happen to update the Docker Compose config such that the Grafana instance requires you to sign in, most likely the username and password will be admin and admin, all lowercase. In this case, you don't really need to sign in right now. You'll already have all of the admin privileges you need to do whatever you want with this instance. So first we can check the data sources that Grafana is connected to. It's connected to the Prometheus data source. It's connected to the Loki data source, which means Grafana is going to be able to query the logs from Loki. Let's make sure of that. Beautiful. And it's going to be able to query the metrics inside of Prometheus. Amazing, which means now we can go and create a dashboard that demonstrates the power of combining metrics and logs. All right, let's create this dashboard. The first step is to add a visualization. This visualization can either query logs from Loki or query metrics from Prometheus. We're going to construct the first visualization by querying for a particular metric from Prometheus. All right, now you'll recall I told you that I'm exporting a lot of fake metrics to the Prometheus data store. So if you go to localhost 9090, you can get an idea of what those metrics are. HTTP request durations, request total, etc. All of these are metrics that will allow us to analyze patterns and trends over time. So this query, just like that, isn't that useful because there are so many requests happening at so many different paths. 2 requests happening on this path, 1 request on that path. Not that useful. So what we want to do is perform some sort of aggregation. Okay, so I want to aggregate by method. So I can do sum by method. All right, putting some brackets around that. And this is a lot more useful. This shows me how many, sorry, apparently I can't speak English, how many post requests have happened at this point in time, how many GET requests, so on and so forth. If we keep executing it, this is going to keep increasing because our thing's pretty hard at work, okay? Cool. Now, what would be more interesting than just looking at the total number of requests per method is analyzing the rate of requests per second. Okay, you get a lot more info out of the rate. So what we can do is in the past 5 minutes, doesn't really matter what time range you choose. Take all the requests that happened in the past 5 minutes and divide them by 5 times 60 seconds, so 300 seconds. So what this will do ultimately is calculate the rate of requests per second for every single path, which is then aggregated by method. And after performing this aggregation for methods of type patch, we get 0.155 requests per second. For methods of type posts, we get 0.156 requests per second, so on and so forth. Now, this is not a PromQL video. If you followed this channel long enough, you'll know that I have a more complete video that teaches just PromQL. So if that's what you're interested in watching, make sure to check out that video after you watch this one. But the purpose of this video is to demonstrate the power of combining metrics and logs and visualizing everything in Grafana. So that same query, we can go ahead and paste it over here, and it's going to create a visualization. So while in the Prometheus UI, we just see the latest value, in a Grafana dashboard, when you specify a time series panel, we can see how that number is changing over time. And it's pretty darn cool how we're able to capture trends and potentially look out for any unusual patterns or anomalies that may arise. In this case, I see a gradual increase in rate almost everywhere. That seems pretty healthy to me. We're going to go along with it. All right, let's call the panel request rate by method. And what I'm going to do is add a unit here that says requests per second. So we'll go to where the heck are you? So requests per second, that's throughput. Oh, I'm looking at it. There you are. We'll go ahead and say back to dashboard. Looking good so far. So overall, we see a steady pattern in the requests per second at a median of 0.14 requests per second. Pretty healthy to me. Now let's assume that at some point, the post requests per second just drops to 0. Something happened in order for post requests to not be processed anymore. How can we verify exactly what happened? Well, that's where we need to visualize raw logs. So if this happened, so let's just say at 1544, post just drops to 0, then we can look at the raw logs, filter by timestamp, see what happened at 1540, and be able to understand exactly what happened. So that's why it's really powerful to have one panel for monitoring metrics and another one for monitoring logs. This one is going to make queries to Loki. All right. And let me zoom out a little bit. For this one specifically, what I'm going to do is use the builder, all right, to use my log, to set up my LogQL query, because I find that with the builder tool, especially for LogQL, there's like a specific order in which you have to specify each operation, and by using the builder, it kind of just orders it for you, which I find is really neat. Pretty cool thing that Grafana did. Now we can query for logs in Loki using labels. Labels are the metadata in a log that Loki actually indexes for querying. And you'll remember in the beginning of this video, I told you that Loki doesn't index every single field in a log. Only select labels that will assist us in querying the logs, and the remaining log content are compressed into chunks. And this allows Loki to be very, very lightweight, in contrast to its logging counterpart, Elasticsearch, which we still use at my work and which I'm personally not in favor of, but I don't make the decisions. So anyway, how does Loki know which fields it needs to index and which ones it needs to compress? When PromQL is collecting your logs, before shipping them off to Loki, you can tell it which fields in the logs you want it to index for querying. Fields like file name, PromQL actually automatically adds based on the source file that it's reading from. In this case, the file is generated logs.txt. So ultimately, all these logs being generated, they're being outputted here to generated logs.txt. That's where PromQL is reading all of the logs from before it ships them off to Loki for storage. Anyways, but the labels I want to actually point you to, draw your attention to, are HTTP method and HTTP status. Here's why. Let me go back to following. Let's go to our promtail.yaml. And here is ultimately where we configure the log collection pipeline. And here inside of pipeline stages, we're telling it, hey, when you're collecting these logs, so let's look at an example of one of the logs and copy and paste it over to here. When you're collecting these logs, look out for the labels method and status. So here we have method delete, and status should be somewhere, and status. Map them to say HTTP method and HTTP status, and actually preserve those for indexing. The remaining parts of each log, compress them into chunks. All right, so you can actually select which fields in the logs you want to be labels, which fields you want to be indexed for querying, and which parts of the log content you ultimately want to be compressed. That's ultimately what makes Loki so amazing and lightweight, is that not everything gets indexed. We also have two labels that automatically get added to every single log, job and service name, and they both have the value of generated logs because ultimately it's been understood that that's where the logs are coming from. Okay, so what we're going to do is apply our first label filter. We're going to query all of the logs that have this label equaling generated logs, which is going to be all of them actually. So let's run this query. And I look foolish because this is still a time series. So go to logs. Okay. Take home message is these automatically added to every log. These ones, we specifically orchestrated that ourselves. Now, in order to refine this query and be able to output more meaningful results, what if this JSON log, what if I want my LogQL query to be able to parse every single field inside of it and make that into a queryable field? Queryable. I wonder if that's even a word. So if I want to extract all of these fields and make them into labels I can query, I need to have an operation that allows me to reformat each log. And because everything here is JSON, I use the JSON option, okay? Run the query. And now if you drill down to each log, now it has many, many more labels that we can use to query for it. Okay, very powerful stuff. Now when to use JSON, when to use log format, etc. These are the most common, so I left you an image here that you can use as reference. We all know what JSON looks like, but in this case, it's just, you know, key value, timestamp value, level, info, etc. So depending on how your logs are formatted, you would need to choose the appropriate operation in order to extract your labels. All right, and now just for the sake of it, what I want to do is add another operation. This one is going to be a label filter expression. And I'm going to say filter by, so we filter by the labels, all right? Filter by HTTP method is equal to post. Run this query. Beautiful. We only see the logs that have the method post. And if you look down, this this query that we're building up, here is actually the raw query that it converts to, all right? And you can switch between your builder mode and code mode, but I find builder to be very helpful for LogQL, as I mentioned earlier. Let's go ahead and call this panel raw logs. Back to dashboard. Don't worry, this is going to look a lot prettier later on, but right now I don't really care about aesthetics. So this shows me the request rates by method, and this only shows me the logs for a single method. We could easily revert it to show the logs for all methods in order for these to be more synchronized, but how can I make sure that they're always synchronized? That's where variables come into play. Instead of hard coding the query to only filter logs for post, I can create a variable that both panels can refer to. So let me go to settings, go to variables, add a variable, and the first variable we're going to add is a query variable. I'm going to call this variable method filter. Method filter. And this variable, in order for it to provide options from which we can select from, we need to make a query to the Loki data source. So we want to query for the label values, and the label specifically is HTTP method. We want to allow custom values, multi-value, or all option. Run the query. Beautiful. Now the method filter exists as method underscore filter, if you'll remember. So now here I can say, instead of HTTP method equals post, I can make things more dynamic and say method filter. That's what the label name was. Run the query. Beautiful. Now it filters based on delete methods, and we need to make sure that we're consistent over here. So here I'm going to perform a label selection. So if you watch my previous PromQL video, you'll know that we can filter using labels. One label that each metric has is, let me make sure, if I perform the following query, what labels does it have? What labels can we filter by? So method, yeah. So method is equal to whatever gets selected by the method filter. So notice how I'm not using the query builder for PromQL, but I am for LogQL. I just find it easy to use the builder for one and not the other. Anyways, now they are synchronized. So if at any point I see something going haywire with delete requests, I can quickly cross-correlate at what time something happened and look at the associated logs in the past 15 minutes, and I'll probably get my answer. But sometimes it can be overwhelming to look at so many logs that have occurred in the past 15 minutes. So you want to apply another filter that allows you to quickly sift through your logs. So what I can do is add another filter, add a new variable. This one isn't going to be based on a query. This one is going to be a text box. Okay, a simple text box filter that I'm just going to call filter. Go back to the dashboard. And here, this filter is really useful for filtering through logs. I'm going to use my builder to add another operation. This one is going to be a label filter, or a line filter. Line contains. And we're going to check if a line contains whatever value I'm filtering by, keep it. Otherwise, don't. So the filter we're referencing is the following. Back to dashboard. Right now, we didn't specify anything, so we still see everything. But let's imagine that suddenly all the delete requests drop to 0. What do? Well, something's probably going wrong. So let's filter by 503. Boom. Now we only have the logs for 503. If I think that it might be related to requests happening on the path, I don't know, front end or whatever, I can be like, hey, there was a 404 at this particular time. This might have something to do with it. Obviously, right now, I can't really simulate any errors, but I hope you can see the power being able to combine metrics and logs into a single dashboard. But now what I want to do is finalize this video by just loading up the entire dashboard so that you can get a good sense of what a good unified dashboard looks like. I went through the liberty of creating this dashboard before starting off this video, just so that I wouldn't have to create all the panels in front of you one by one. That would just be really painful to edit. But anyways, we'll import the dashboard. And this looks pretty good. On top, we have a bunch of metrics being queried from Prometheus. And on the bottom, we have raw logs. The metrics allow us to analyze trends and patterns over time. And the logs allow us to pinpoint specific events that occurred that may explain unusual patterns and behaviors that we may notice over here. And we have pretty much all the same filters that we talked about before, with a service filter as well. So I can filter by status. Let's just, so this shows us the status code distribution for all requests that were 203, 205, 200, whatever status codes over time. We can see what the slowest requests were, when they occurred, and you want to find out why the request was so slow? Well, you can go in the logs and be able to verify that all the same. So if I want to know what's going on with the request/empower, let me filter for that value. Why did this take so long? So now, if I go down to the logs, there was a request made on that path that had a status of 502 at 4:23:33. So that might explain what's going on. And that's pretty much where I want to leave this video. I don't want to wrap up this video until we do some cleaning up. So let me just run docker compose down to make sure all the containers are gone. Let me run docker system prune -a to remove all the data. That's pretty much it. I hope you enjoyed this video. If you did, make sure to hit that subscribe button, and I'll see you in the next one.